In this video, we will look at a chromosome with 3 linked loci to determine different things. Here's a map of a chromosome looking at 3 loci which show color of a bunny, ear shape, and fur length. Let's say that the brown fur is dominant over albino, droopy ears are dominant over perky, and fluffy fur is dominant over short. In our parental generation, we are going to be crossing a homozygous dominant female with a recessive homozygous male. Here are the chromosomes for these. This means that when crossed for our F1 generation, we are going to get a heterozygous bunny with the chromosomes shown here. This bunny's phenotype will be the same as the mother's because of her dominant traits. Next, we are going to do a test cross with this female heterozygous bunny and a homozygous recessive male. This ensures that the phenotype will be determined by the heterozygous female. So let's see what gametes this is going to produce. The first thing that could occur is a single crossover on the chromosomes. This crossover could happen over R1 to make our SCO1. It can also happen on R2 to make our SCO2. Shown here are the genotypes that occur from a single crossover in their corresponding chromosomes. The next thing that could occur is a double crossover, which would produce these genotypes in corresponding chromosomes. Finally, no crossover could occur, resulting in the same genotypes as the original. From the crosses just shown, I have made this table laying out the genotypes we saw being made and the corresponding phenotypes. Next, let's determine the probability of these 4 events happening. Let's say that the distance between the first 2 alleles is 20 centimorgans, and the distance between the next 2 is 15. Let's also say that our coefficient of coincidence is 0.8. Using this table, we can determine the probability of a double crossover, single crossover, and no crossover occurring. From the table, I have filled out the corresponding values. And going back to this table, this is how the values fall into place. As you can see, no crossover has the highest probability of happening, and double crossover has the least.